be negative acceleration. So, let's say something is accelerating at 10 meters per second, all right? Starts from 0. After 1 second, how fast is that object going?
10.
10 what?
Meters per second.
Thank you. After 2 seconds.
20 meters per second.
3.
30 meters.
Beautiful. Beautiful.
I can do that.
All right? That acceleration will always be constant when working with these within this chapter. Okay? Make sense? So your acceleration graph will always look, if this is acceleration and that's time, will always either look like this, and that would be a negative acceleration, or this, positive acceleration, right? It has acceleration. Just because it's a flat line doesn't mean it's 0.
Wait, it's not even slanty?
No, because if it's slanty, the acceleration here is something, and the acceleration there is greater, right?
Can we all redo this homework?
I definitely messed that up.
That's right, then.
Okay. Thank you. Go over.
Yeah.
Like,
Looks like we have to, huh?
an example.
I think get it.
Because I think I got it.
All right, let's do it then. Bus. Yeah.
So just speaking from like a formula viewpoint, knowing that each one is a derivative of the other, you can kind of figure that goes straight line, slant line, and then whatever the original position is.
Yes.
Just making sure that's like valid logic.
Was there a question there?
I was wondering if that's like valid logic to
Yes.
use that.
Yes. All right, so I told you guys to skip the first 2 pages, right?
Yeah.
Great. So number 3, sketch graphical representation. Okay, a separate graph for position, velocity, and acceleration versus time. You have an object with negative initial position that's moving rightward with negative acceleration. Well, rightward. This is rightward.
So it's positive.
So that's positive, right?
Yes.
But right word on the graph would be time. If you're moving right on the page. If you do time as the x-axis.
Yeah, but that has nothing to do with the x-axis. It's just saying that anything going towards the right.
It's moving in positive direction.
Right. This
So-
is not the graph.
Yeah. The line would be going up. Correct? Because it's moving from a negative to a positive.
Yes. Let's take a look at that. Okay. First thing here, we're gonna first do the acceleration versus time. Right. Hi.
Straight
Yes.
line under the time. Yeah. Yeah.
Right. Correct. Negative. Positive. Why is this not slanted?
Acceleration is constant.
So is this object accelerating?
Yes.
Yes, it is. Just in the negative direction. Okay. Now, let's look at the x versus t graph. Is this object speeding up or slowing down?
Slowing down.
Slowing down. And is starting from a negative position, right?
Right.
Can it be anywhere? Does it have to be on that?
Well, time equals 0, right?
Oh, okay.
That's time 0.
Yes.
Just start there. Okay? Should look something like that. Right? Starting the negative position. Going towards the positive position. And if you look here, though, it's covering less distance over time, right? It's covering less and less distance over time. Here, and there, oh, let's say, sorry, here and there, it's covering that distance, okay? And then from the same time interval, it's only covering that distance. So it's covering less distance over time, which means that that object is slowing down. Okay? And then finally, the velocity versus time graph. Any guesses? Any answers? Yes, Thomas?
You start in the positive and you go down until you reach 0 in a straight line.
Okay, do we say it stopped?
You just have to go down.
Yeah, it didn't say it stopped, so you don't know if it went, you don't know if it reaches that, but it is going to be a straight line, right?
Yeah.
That's an important piece. Why is it not a curved line? Colin, why is it not a curved line?
The velocity is in exponential. It's not exponential.
Why is it not a curved line? What causes velocity to change intermittently? Is the velocity changing?
Acceleration thing?
Yeah, is the velocity changing?
Yes.
Yes, it is. But why is it not a curved line?
Because it's changing at a constant rate.
Yes, because velocity is changing at a constant rate. It's always changing by the same amount. All right. B. Object with positive initial position. So we already know to start above the x-axis on the x versus t graph. X, t, b, t, a, t. Beautiful, beautiful. All right. Moving leftward with positive acceleration. Something moving leftward is negative. Stay with me, Ivan. Something moving leftward is negative. Okay, is this object slowing down or speeding up?
It's slowing down, but it's positively accelerating.
What do you think? I have all the answers to choose from.
Speeding up in the negative direction.
It's moving faster.
It's
But in
slowing down, but
slowing
it's
down, but,
positively accelerating.
Yeah.
Something is moving in a negative direction. Right? It's moving in a negative direction. Which means acceleration, you said, is positive, right?
Indeed.
Is going in this direction. So if I'm moving in this direction and there's acceleration in this direction, am I speeding up or slowing down?
Slowing down.
Yeah, right? You hit your brakes on your car, you're still moving in this direction, but the acceleration is in the opposite direction. So, this is going to be like that.
That's not curved.
It is curved. I just really stink at drawing. I can't make curves. Thanks for bringing that up, by the way. Is that better, Elijah? You even look at it. All right? So you can see, as time passes, this object is getting slower and slower and slower. Okay? Going in the negative direction. V for velocity. What's that doing?
It's moving at a constant diagonal towards 0. From
Why is it constant?
Because the acceleration is constant.
Thank you. Where do I start it? On the below the x-axis or above? Below. below the x-axis. Hey,
Why are we starting it below the x?
why are we starting it below the x-axis?
I made like 2 comments about bisexual
I just want to put my fist in your suckhole.
You guys are on camera.
I just want to, Jesus, I just, like, something about your face, I just want to, God. I want to rip it off.
Steven, you're gonna have to edit.
Yeah, there's going to be a lot of edits, right?
Uh-huh.
You know the one guy movie?
He's already got
Yeah, I
such
know,
great
he-
footage.
Alright, why is it on a
Dang it,
negative?
don't edit that out.
Why is it on a negative? Huh? Huh?
Because it starts at a leftward, like going left-ish. Serious? And are you serious?
I'm on TV. Okay, listen. Do you know why? Do you know why?
Oh, Jesus!
Do you know why?
No one knows. It's a mystery.
Go ahead, Sasha.
Because it starts moving leftward and leftward counts as negative, it starts in negative velocity because it's going at a relatively quick speed downhill. But because the it's moving leftward, it's moving leftward relatively quickly. But because the acceleration is positive, it slows down until it reaches 0, and then it starts going potentially the other way. We're not really
Right, we're not sure. It doesn't say about anything turning around. But that's correct, guys. Guys, it's on the negative side, right? It's on the negative side because delta x is negative, right? Isn't delta x negative? Because delta x equals x final minus x initial, right? And this, over time, equals essentially average velocity, okay? And if you take it at a very, very small instant in time, it equals instantaneous velocity. We'll talk about that later. So therefore, velocity is negative. Okay? Positive acceleration, and we just go, woo. That's a straight line like that. Okay. All right? We good?
Yeah.
Object positional at rest, blah, blah, blah. Everyone should be able to do that one, right? All it is x versus t, and it's in the positive and just straight line, horizontal line. For velocity, it's along. There's no velocity. It's on the axis. Acceleration, it's on the axis.
But for acceleration, it's just a straight line across.
Along the x-axis, yes. Okay. All right. Oh my goodness. Which one do you want to do of the basketball, airplane, or ball?
The airplane.
Basketball player.
Basketball plane?
Yeah, the basketball player.
The ball and airplane plane.
All right, basketball. Basketball is my favorite sport. Are you taping still?
He's gonna take
God, you gotta freaking work the edit machine.
Why are we taping?
Burn my face. All right. A basketball player running forward slows to a stop and then starts speeding up while running backwards. Forward is positive, backwards is negative. Okay? So he starts like this. So he didn't start yet. Now he starts and he slows down. Right? My x is what? I'm running forward. My x is what? Charge positive?
Goes down and like.
It's like a roller
Yes. Does it ever, well, hold on, what's the what?